The universe was dark at the beginning. The cosmos had been jolted into life by the Big Bang, and the new landscape swarmed with particles, chaotic and hot, before cooling down to a serene expanse of hydrogen and helium. Then, amid the fog, something began to happen. The first stars were formed when pockets of gas collapsed in on themselves and ignited due to gravity. The glowing orbs began to cluster, generating the earliest galaxies, sloppy, malformed objects, not as polished as our Milky Way, which has exquisite spirals today. The youthful galaxies, on the other hand, shine brightly in the darkness, illuminating the universe. They have to have been stunning. However, before you can grasp what the James Webb telescope discovered about Planet X and what it has revealed, you must first understand what Planet X is and the history behind it. So, let's begin the video. When Sedna's unusual orbit was discovered in 2004, it sparked conjecture that it had collided with a large body other than one of the known planets. Sedna's orbit is unattached, with a perihelion distance of 76 AU that is far too great to be attributable to Neptune's gravitational interactions. Several authors hypothesized that Sedna entered this orbit after colliding with a big body such as an unknown planet in a distant orbit, or another star that passed close by to the solar system at a later date. The finding of a second sednoid with a perihelion distance of 80 AU, 2012 VP113, on a similar orbit in March 2014 reignited speculation that an unknown super-Earth still existed out there. Astronomers Chad Trujillo and Scott S. Shepard discovered similarities between Sedna's orbit and that of 2012 VP113, and numerous other ETNOs in 2014. They proposed that their orbits were being perturbed by an undiscovered planet in a circular orbit between 200 and 300 AU. Later that year, Ral and Carlos de la Fuente Marcos proposed that the similarities of so many orbits, 13 at the time, required two huge planets in orbital resonance. They determined that the nearer planet had a semi-major axis in the range of 300 to 400 AU, a low eccentricity, and an inclination of approximately 14 degrees, based on a larger sample of 39 ETNOs. Furthermore, Batygin and Brown of the California Institute of Technology suggested a plausible orbit for Planet 9 in early 2016, explaining how the comparable orbits of 6 ETNOs may be explained by the planet. This theory has also been proposed to explain ETNOs with orbits perpendicular to the inner planets, and others with high inclinations, as well as the tilt of the Sun's axis. Planet X, also known as Planet 9, was first thought to orbit the Sun in an elliptical orbit with an eccentricity of 0.2 to 0.5 and a semi-major axis of 400 to 800 AU, or 13 to 26 times the distance between Neptune and the Sun. It was estimated that the planet would take 10,000 to 20,000 years to complete one full circle around the Sun, with a 15 degree to 25 degree inclination to the ecliptic, the plane of the Earth's orbit. The aphelion, or farthest point from the Sun, would be in the approximate direction of the Taurus constellation, while the perihelion, or closest point to the Sun, would be in the general direction of Serpens, caput. If Planet 9 exists, Brown believes that a probe might reach it in as little as 20 years, utilizing a powered slingshot trajectory around the Sun. So, let's discuss Planet X's mass and radius now. It is estimated that the planet has a mass of 5 to 10 times that of Earth, and a radius of 2 to 4 times that of Earth. Brown believes that if Planet 9 exists, its mass is sufficient to empty its orbit of massive bodies after 4.5 billion years, the solar system's age, and its gravity dominates the solar system's outer edge, making it a planet by present standards. Planet 9, according to astronomer Jean-Luc Margot, meets his requirements and would qualify as a planet if and when discovered. Now, let's start at the beginning. Planet 9's origins have been investigated, including ejection from the vicinity of known massive planets, capture from another star, and in situ development. Batygin and Brown proposed in their first paper that Planet 9 formed closer to the Sun, and was expelled into a far-flung eccentric orbit after colliding with Jupiter or Saturn during the nebula era. The eccentricity of its orbit was then lowered by the gravity of a nearby star, or drag from the gaseous leftovers of the solar nebula. Its perihelion was elevated as a result, placing it in an extremely wide but stable orbit outside of the influence of the other planets. The chances of this happening are thought to be in the tenths of percentiles. Planet 9 could have accreted more mass from the protoplanetary disk and grown into the core of a gas giant if it hadn't been thrown into the solar system's outer regions. Its expansion was instead halted early, leaving it with a lesser mass than Uranus or Neptune. Planet 9's capture in a stable orbit could be aided by dynamical friction from a large belt of planetesimals. As the gas was cleared from the protoplanetary disk's outer portions, recent models suggest that 60 to 130 Earth-mass disk of planetesimals developed. Planet 9's gravity would affect the courses of the various objects as they traveled through this disk, reducing Planet 9's velocity relative to it. Planet 9's eccentricity would be reduced, and its orbit would be stabilized. A planet approaching Neptune would have a 20% probability of getting captured in an orbit similar to that postulated for Planet 9, if this disk had a remote inner edge of 100 to 200 AU, with the observed clustering more plausible if the inner edge is at 200 AU. The planetesimal disk, unlike the gas nebula, is likely to have been around for a long time, allowing for later capture. With the origins of Planet X out of the way, let's return to the main subject, which is, of course, what has been discovered with the James Webb Space Telescope. The JWST is an all-purpose telescope that can look at our solar system's planets and moons, as well as asteroids and comets. It can examine planets that belong to other suns, and planets that don't belong to any star at all, and study interstellar dust particles, supermassive black holes, and mysterious luminous objects known as quasars. This is the telescope that aspires to capture almost everything. Webb's designs have had plenty of time to be conceived by scientists. The observatory has been in the works for 25 years, or even longer if you include the years since NASA first conceived the plan. After more than 30 years in operation, astronomers have wrung practically every discovery out of their beloved Hubble telescope, which is continuously collecting whatever the universe sends its way. They're excited to observe the universe through a considerably larger telescope and in a completely new light. Webb will scan the universe with infrared light, which can pass through matter more easily than visible and ultraviolet light, which Hubble uses to survey the universe. Webb's devices can peek through alien air and even examine if the molecules in other atmospheres are the same as our own. Nicole Lewis, a Cornell astrophysicist, is excited to test this on a system of 7 rocky, Earth-sized worlds 40 light-years away. Meanwhile, astronomers will be pondering the beginnings of the universe, which occurred some 13.5 billion years ago. The primary goal of the Webb telescope has always been to capture the earliest light, which has been so stretched on its voyage through the expanding universe that it can only be seen in the heat of infrared by the time it reaches us. The furthest galaxy discovered by Hubble existed 500 million years after the Big Bang. Astronomers believe galaxy formation began far earlier than that, and they anticipate Webb will be able to look far enough back, maybe as early as 100 million years after the Big Bang. According to Steve Finkelstein, an astrophysicist at the University of Texas in Austin, they think it can not only detect galaxies from that time, but also discern what they're made of. To us, 100 million years seems unfathomably lengthy, but on a cosmic scale, it's a blip on the screen. What do you think about the James Webb Space Telescope and Planet X? Please let us know in the comments below. Till next time!